Hello everybody, my name is Sylvia Lima and I'm with UcamX Belgium. I am happy to be your host in this video about UcamX SmartDRC and the wide range of possibilities it gives. It supports users checking and even repairing PCB data to optimize the PCB production flow and reduce the scrap rate. I will use a standard job to show how it can be used and how easy and variable the setup of the SmartDRC is. Let's start with the setup. Every manufacturer of PCBs is handling the DRC check differently. For example, some prefer to go through the DRC based on the check type, like this one here, first the pads and holes, then the annular rings, the clearances, the lines and silk screens, and some special tests. And in this case, they repair after every check before doing the next. Others prefer to do it all in one run and filter through the found issues via error handling. I will explain that a little bit later. Of course, there are myriads of methods to do DRC checks, and we try to support all of them by providing a flexible tool which can be set up to a lot of different requirements, like copper thickness, different customers, the IPC classes, and so on. I will show this menu a bit more. For that, I use, for example, the clearance, and I go to Edit. The DRC class editor is split up in 4 sections, and the first section here has on the left side every specified class and subclass. Classes are in capital letters, subclass in small letters, and for example, inner, outer, and outer top are subclasses of the layer class. You can specify different sets, for example, a layer set, which contains all the DRC checks to be executed on a layer with a specific class or subclass, or the layer-to-layer set, which contains all DRC checks to be executed on the combination of 2 layers with specific classes or subclasses. As example, as a layer set for outer, or a layer-to-layer set outer to mask. The second section contains some global settings, for example, the tolerance. The tolerance field displays relative tolerance. All errors that are within this tolerance are displayed in error handling as accepted errors. The Use Netlist toggle. You click the Use Netlist to ensure the clearance values between objects on the same net are not flagged as errors. The third section displays the options of layer checks or layer-to-layer checks. Here, the content of a layer-to-layer check, or if I switch to a layer check, all that possibilities. We have a lot of checks in the layer check area. I will not go through them one by one, but some of the most important things. So for example, all the clearances between pads, from pad to track and between tracks, or the P-level SMD, which checks the clear area between a track and a pad included in the same net. Same for round objects, and a lot of other things will be checked without a value. For example, the single track checks for tracks that are not connected to any other object on the same layer. Or you can check the track angle, which checks the angle of a track, and when a track runs at an angle other than a multiple of 45 degrees, it is entered into the error list. And yeah, a lot of checks, and we will have a look at some of them later on. Now have a look at the layer-to-layer checks. There we, for example, have the pad clearance, which checks the minimum clearance between a pad and the primary layer and every other object on the secondary layer. That means outer mask, outer is a primary, mask is a secondary. So if we have a look at ring layer 1 to layer 2, it means the ring from outer to mask is meant in this. You can have it the other way around, but for the outer to mask we use the ring layer 1 to layer 2. We have another often used check in here, exposed tracks, that checks the minimum clearance between tracks from layer 1 and pads on layer 2. For example, if a mask is exposing a track. And here we have the non-value checks too. So for example, we can check isolated pads on layer 1, means if I have a pad in copper without a mask, or the other way around, a mask opening without a copper pad. The last section contains the buttons where you can save a new check with a new name, where you can reset to what you opened, to save the same set if you have changed it and want to override it, or you can run a check directly. So if you are the person who is creating all the predefined checks for the colleagues in CAM department, for example, then you can first go and check if all settings are as they should be. So to make sure they can directly work with it without giving a thought at the settings. I think this is enough for the DRC setup now, as this video only gives a small overview. But I think it is clear how easy the setup is, and it is even easier and faster to use it. As our SmartDRC contains the possibility to repair issues directly, I will now show the setup for the repairs. It is very easy to specify exactly what you allow as repairs. You can either load an existing set or you can create one from scratch. You have pictures for every repair method, what makes it simple to specify what and how you want to repair an error and to what extent. For example, the optimized shave. You have the shave limit in percentage and a minimum ring which is not to be violated. And you have the picture which is showing you exactly what that means. This is for all the existing methods, so pad to pad, pad to track, the track to track, or the peelables, the ring you can expand or shrink, the gap expand for the thermal, or combined sets for multiple pads or multiple tracks. Of course, this is not a repair to the extent of our yellow adjusters. It is a fast way to do small repairs semi-automatically. The copper adjuster, for example, optimizes the whole copper layer automatically and is used before SmartDRC, so the error count would drop dramatically. Let's see what we have in this layout. You can open the SmartDRC via main menu, so go to Tools, Verify, Design Rules, SmartDRC, or you can use the much faster way with the shortcut icon. The user is getting directly to the setup window and has all configurations provided by the setup available. I use the same I have shown to you before. Everything in here is active. The user can decide to say, okay, I want to check the mask later on, or he can do it all in once. He knows exactly what class is involved, what check is in there, the required value, and if there is a tolerance. The tolerance field in the options is the same you have seen in the setup. I will create a job net list for this, and I will not select the faults, because select faults means all violated objects will be selected. That makes a lot of highlights on a very small area, and I would like to show it a little bit clearer, so I will not select the faults. I get an overview back. So all signal layers were active, all drill layers were active, and all extra layers were active. The DRC found 2,336 errors, and in the results tab I can see all of them. Filtering through them is quite easy, so I have the class in the front and I have the checks we specified in here with the required value and the minimum which is found. The violated ones are marked up in red, so it is quite fast to go through it and see what to do. In here we see a lot of errors, and I only want to see, for example, now the pad to track. To have it a little bit more visible, I zoom in and go through the checks, and there I see pad to track is violated. Yep, the first error always shows the most violated one, so the one in this case with the smallest clearance with 79 micron. If I go through them, the next one is already a little bit bigger, but still violated. And the user can decide what to do with it, so make the region smaller if allowed, or contact the customer if some other changes are allowed to do. If I have a look at a layer-to-layer check, for example, the outer to mask, and take here the ring, minimum ring, layer 1 to layer 2, I see I have errors here. Blue is the mask. And if I go to skeleton, I see, yep, there is no pad below that, so there is no annular ring. Therefore, the minimum found is 0, and that is an error. If I go back there and scan through it, I get to other errors. In this case, there is a component, and the copper pad is bigger than the solder mask. I have some of them, so If I go back to the first one and say I would like to get a proposal from our repair methods, then you can see the repair is proposing an expand of the second circle. Second circle means outer mask, it's a mask, the layer 2. If I don't want to have that, I can have a look at other possibilities. Yep, the other possibility is that we neck the copper pad. But I don't like that so much, so let's try to make the mask bigger. If I do that, automatically you see the mask is repaired and the status is repaired. You see it in the summary too. One of the errors is repaired. I do it again on the next one. 137, one repaired. I click here and 136, two repaired. If we use a layer check now, for example, mask pad to pad, I see, okay, the mask openings have not enough clearance, and again I have a repair proposed. Necking the pad, that means the solder mask opening, because it is only the mask available. And if I don't like that, I can have a shave. It is the circle again, it is the mask which will be shaved. And if I go to repair, I see the same thing in here. One error of 2 is repaired now. This is a way to go through it. Of course, some of these errors we see here can be changed differently or even ignored. If I have a look at the isolated pads on layer 1, I have quite a lot of them, and of course it is the wires which are not opened in the mask. If I now go there and place a mask opening on every wire hole, this check will be going to 0 and nothing would be read here anymore. Of course, when I have a look at all the issues we have, I can filter through them via the layer selection. So, for example, in this case, I have 0 errors on the solder side. If I go to the top layer again, I have my errors back. I think that is enough for now. You have seen how fast our SmartDRC check is and how simple it is to filter through our errors. On top of it, you have seen some of the repair methods. You can even have repair all of them, so that means I click on something in here. If I say repair all, it would try to repair all the errors. I am at the end of the demonstration now. The last information I would like to share is how you can get detailed information about each field I introduced. It is very simple. As a UCAM user, you open the help on application from the main menu, and you have all the needed information on your fingertips. Type SmartDRC into the search window, and you directly have all the topics available. For example, the setup window. We went through that, and you can see directly in here what I explained. The layer check link and the layer to layer check link. If you open that, you have the possibility to see what is in there. The smart design rule check, so we are back to that window. The other way to find fast help is via the Contents tab in here. Here you use the same way as you use in UcamX to get the information. So, as I've done in the beginning, I go to UCAM, I go to the main menu bar, I open the Tools menu, Verify, and go to the Design Rules. And again, I'm on the page of the Design Rules, and I have the possibility to go to the Smart Design Rule Check. I have the Setup window or the Results window, and so on. Every information you are looking for is available. I hope this video gave you a useful overview of our SmartDRC and an idea of how SmartDRC can support you to check and repair layout very fast and efficient. Thank you very much for your attention. If you are interested in a more detailed demonstration, maybe even on one of your data sets, please contact your local UcamCo support or contact us on sales@ucamco.com. Goodbye.